How do you make incredible sounding drums from scratch? In 24 minutes, you'll have the answer. To begin with, we must first understand what makes up a great sounding drum hit. I break down the process into 3 layers: transient, body, and noise elements. This method allows for precise control over the characteristics of each hit while enhancing their realism and impact. Kick drum. Starting with the kick, all 3 layers are coming from Kick 2 by Sonic Academy. Addictive Drums is also providing an additional noise ambience layer. Here's how they sound together. You can download this project on my Patreon alongside a bunch of other perks like video feedback on your tracks, extra tutorials, and other goodies. Now, let's peel back the process and start with the most important layer, the transient. This layer typically consists of a short, sharp sound that adds the initial impact to the drum hit. It's responsible for the click or attack of the sound. Here's how the transient layer sounds. Now, if we strip away the LFO tool, it's just a raw kick drum. But here's where the magic happens. LFO tool is automating the volume to trim away everything post the initial click of the kick. We could draw in the automation manually, but why make it more complicated? LFO tool makes the process convenient and easy to adjust. Now, let's talk EQ, which is serving a dual purpose. We're boosting the fundamental to give our sound more body and cutting away the excess frequencies. Let's listen to the transformation. Boosting the fundamental frequency of a drum involves emphasizing its primary pitch. This tweak enhances its core character, at least to my ears. The frequency cuts are our secret weapon against unnecessary sound that clutters up the signal. Why is this crucial? Because it allows us to crank up the overall loudness of the sound, utilizing every bit of available amplitude. One trick worth highlighting is that all of these EQs in the project are set to linear phase mode to avoid phase distortion or smearing. In the standard minimum phase EQs, boosting or cutting frequencies can introduce phase shifts, leading to a not so friendly phenomenon called phase distortion or smearing. Smearing is where the phase relationships between different frequencies in a signal are altered, leading to a reduction of the signal's clarity, reduced transient definition, and an overall blurry sound. Linear phase EQs avoid this phase distortion by processing the entire frequency spectrum with consistent phase relationships. The downside is that they eat a lot of CPU, but in a drum synthesis project, I don't tend to have more than a handful running at once. Next up is my go-to saturation plugin, Saturn 2 by FabFilter. Saturation adds in both harmonic and inharmonic overtones to a sound. Harmonic overtones are the secret ingredients in our sonic potion. They're frequencies that align with integer multiples of the fundamental, so overtones that follow the harmonic series. On the flip side, we have inharmonic overtones, the rebels that don't follow the harmonic series. Together, they create a symphony of richness and complexity, mimicking the distortion from analog gear like tape machines or vintage consoles. I won't bore you with repeating the plugin chain details, as this chain is duplicated across each layer, so I'll skip mentioning these plugins again aside from LFO tool. Moving on to the next layer, the body, which is everything after the transient. The body layer provides the main tonal characteristic of the drum hit. It's the sustaining companion that follows the transient, giving the drum its fundamental pitch. Here's how it sounds with the same plugin chain we've previously covered. Then, alongside the transient layer, as I've mentioned, the plugin settings echo our earlier discussion, with a slight deviation in LFO tool. I'm delicately fading in the kick, effectively removing the transient to seamlessly meld it with the one designed for the task. When layering drums, volume shaping is the unsung hero. It's our shield against phase cancellation issues. Adjusting the attack of each layer ensures that our elements play well together, contributing to a cohesive and well-balanced sound. The final couple of layers are the most interesting, adding a touch of realism to an otherwise very electronic sound. We've got two layers. One is just a whisper of pure white noise. The other is a high-passed acoustic kick drum from Addictive Drums 2, injecting the natural sound of a drum's resonance and room ambience. By themselves, these noise layers sound, well, terrible. The magic comes from how these layers collide with the electronic elements. Quite a transformation, right? The synergy of these layers is what creates a realistic sounding kick. Remove any layer and the tonality is lost. The plugin chain remains consistent with two minor additions. Firstly, the trusty LFO tool is ensuring nothing overshadows our transient and body by fading these layers in. The real difference is isotope trash, which is copied across both noise layers. I'm using both instances to add grit or top-end fuzz to the sounds. Here's a before and after. The finishing touches to the sound can be found on the bus processing. Here's a before and after of everything on the group channel. First, a surgical move, removing any stereo information with Voxengo's MSED plugin. Saturn 2 follows this up, adding some tape saturation and some crude EQ sculpting to shape the kick's tonality. This tool plugin is lowering the signal by 15 decibels, a move that allows me to drive it hot into the saturator, which often yields better results. Next, enter the ever-reliable transient shaper, a sculptor of sound over time. Just a delicate touch to increase the attack and decrease the sustain, making the drum transient more clicky and shortening the length of its tail. ProQ is then doing some basic shaping of the sound, removing the lows under 25Hz and some mud around 500Hz. The first boost here is increasing the pop of the fundamental. The boost around 5 kHz is increasing the kick's presence, emphasizing this peak here, which sounds very clicky. The trusty LFO tool is slicing off some of the tail, reducing the sound's length. I like playing with this to produce variations of the kicks to bounce out. I also use this waveform view in LFO tool to see if there's any issues that need fixing, like the transient being too loud or the body too quiet. I'll speak more about using waveforms in the next section covering the snare, which we'll now jump into. Snare drum. The snare drum is the most interesting sound of the three, and the hardest to craft. Here's how it sounds. Comprising this sound are a total of 6 layers, following the same layering principle I explained earlier: transient, body, and in this case, 4 noise layers. Here's each on their own. The plugin chain and reasoning mirror our earlier discussions with the kick drum. The one subtle shift is that the white noise is now coming from Serum instead of kick 2. The only difference between these two noise channels and the ones on the kick is a trash 2 on the second noise channel, infusing the top end of the snare with a delightful crunch. As with the kick before, I've got an acoustic drum hit from D.A.W drums, high-passed and faded in with LFO tool. These noise layers are the tail of the sound, so I'm using LFO tool to ensure they emerge after the transient and the body have had their say, minimizing any phase issues. I've mentioned phase a few times, so let's quickly cover the subject in more detail. Phase cancellation. In audio, phase refers to the position of a point in a waveform cycle relative to a reference point. A waveform is a repeating pattern of a sound wave, and phase describes where in that pattern a particular point is located. It is often measured in degrees, with a complete cycle being 360 degrees. Now, why does phase matter, especially when layering multiple drum sounds? When 2 or more waveforms are out of phase, meaning their peaks and troughs don't align, we step into the realm of phase cancellation. This phenomenon occurs when the peaks of one waveform meet the troughs of another, resulting in a reduction or even complete elimination of certain frequencies when they're summed. When these out-of-phase waveforms are combined, or summed, their energies clash, leading to a reduction in overall amplitude. This occurs because the peaks of one waveform align with the troughs of another, creating the cancellation effect, diminishing the sound's intensity. And a diminished intensity is the last thing we want when designing drums, particularly in electronic music. For those new to music production, it's a common pitfall. Often, it stems from using samples that already contain out-of-phase drum layers and compounding the issue by layering them further. The result? A phase nightmare that can destroy the clarity and impact of your drums. Altering the phase of layers can be done by changing the timing of sounds, but avoiding cancellation issues is best done through creative layering, as we've seen throughout this tutorial. To adjust the timing of sounds, there are three main options. The one I turn to most often is the versatile and free plugin Latency Delay by Voxengo. It allows me to meticulously fine-tune the timing of any sound in a project. Another option in the phase altering arsenal is M Auto Align by Melder. This powerhouse automatically synchronizes the timings of every channel an instance of this plugin is placed on. A word of caution though, it can be hit or miss, and your mileage may vary. A third option is flipping the phase or polarity of one of your layered sounds while listening for the optimal combination. When the waveforms align perfectly, you'll hear a fuller, more powerful sound. In the realm of drums, the transient and the body are the sacred sections to protect from phase issues. The noise layers being out of phase is not an issue, as they're not there for impact, but simply serve tonal purposes. Jumping back to the final layer of the snare, which is a high-pass sample that I'd previously made. I'm again using LFO tool to shape its volume. Now, let's peel back the layers one by one so you can hear the difference each is making. Like with the kick, each noise layer is adding its unique flavour to the overall snare, giving it a sense of realism. The bus processing mirrors the kick, saturation, transient shaper, EQ boosting the fundamental and cutting away some frequencies I didn't like, and a final LFO tool to rein in the decay. Here's a before and after of the whole chain, then plugin by plugin. Hats. Let's now unravel the final sound, the hat. To create this, I duplicated the snare group, removed a couple of layers, and pitched the transient up. Here's how it sounds collectively, as well as each layer individually. Notice the transformation of Addictive Drums from an acoustic snare to a hat, still carrying the processing from its origins. The EQs have been adjusted accordingly to match the frequency content of the hat. The boosts that were targeting the fundamentals have been removed, and the low cut has been increased to around 200 Hz, as there's nothing under that I need present in hats. I'll play the hat again now, while muting and unmuting each layer, so you can hear the difference each is making. Following in the footsteps of its companions, the bus processing consists of saturation, transient shaping, an EQ cutting away some frequencies I don't need, and a final LFO tool to control the decay. Here's a before and after of the whole chain, then plugin by plugin. Oscilloscope. An important unmentioned tool that I used while crafting these sounds is the oscilloscope, akin to a sonic detective's magnifying glass. Using an oscilloscope to monitor waveforms can provide valuable insights into the characteristics of a drum hit and help identify potential phasing issues. When gluing together a transient and a body, it's important to see how they line up and if there are any necessary volume adjustments that need making. When crafting drums, there are two main things I'm looking for. The first is how well the transient and the body are gluing together. Is one element too loud, drowning out its counterpart? I'm looking for a shape resembling a horizontal Christmas tree on the oscilloscope. Having an oscilloscope open highlights any issues, guiding my adjustments when using tools like LFO tool to fine-tune the start time of the body and the end time of the transient for perfect alignment. The second aspect I'm looking for is the symmetry of the waveform. I'm striving for a symmetrical waveform, meaning the positives and negative halves of the waveform are roughly equal. This pursuit of symmetry isn't just an aesthetic preference, it's a quest for balance, a guarantee that the amplitude is being maximized, allowing the drum to reach its full sonic potential. Summary. The real secret, if there is one in drum synthesis, lies in the art of separating the sounds into their constituent parts, then layering and sculpting until the perfect sound is unearthed. In summary, the three stages are: 1. Separation of layers. Breaking down drum hits into distinct layers, the transient, the body, the noise elements, lays the foundation for precision and control. It's the starting point where the sonic palette is defined. LFO tool keeps each element separated, avoiding phase issues, but also allows for fine-tuned control over each individual element. 2. Linear layering. The magic unfolds as each layer is introduced systematically. Beginning with the transient, that initial punch sets the tone. Then the body adds pitch and tonal richness, followed by the noise elements, bringing life and realism. It's a linear evolution, each layer building upon the last. And 3. Sculpting the sonics. The sculpting process is where the true alchemy happens. EQ adjustments boost the fundamental, cut away unwanted frequencies, and shape the character. Linear phase EQ algorithms preserve the phase relationships, avoiding smearing and maintaining clarity. Saturation introduces harmonics, adding warmth and presence. Tools like transient shapers can further enhance the sound to taste. Every plugin and every adjustment contributes to the intricate dance of frequencies and overall tonality of each drum hit. It's worth noting that my workflow is not static. It's in constant evolution as I learn new techniques, evolve old workflows, and my favourite, discover new plugins. While the drums in this example exhibit a standard sound, mixing in elements like Foley will infuse uniqueness into the drums, meaning the sonic possibilities are limited only by your imagination. Thank you for your viewership, attention and support. Until next time.